Now let's just move on further towards a new topic which is called as a lines parallel to the same line. So as you can see from the heading that we are talking about the lines that are parallel to the same line. So let us suppose if I'm just talking about any particular given line such that there exists a line which is parallel to this yellow line, and there exists another line that is nothing but parallel to this particular yellow line. So now we have to prove that whether these two blue lines are actually parallel to each other, because this is the given line and I have taken this line parallel to this one, I have taken this line as parallel to this one. Now I just wanted to prove that whether if a line is parallel to a given line, another line is parallel to a given line, then they can be parallel to each other or not, which leads us towards an important theorem. And the theorem says that lines which are parallel to same lines are parallel to each other. So now I am going to prove that the lines which are parallel to the same line, they are parallel to each other. So let us suppose if I'm just taking a figure for this one. Here I have taken the lines L, M and N. So let us suppose if I'm starting with the given conditions that what are given over here. So I have actually taken the three lines L, M and N such that M is parallel to L and N is parallel to L. So I have taken M being parallel to L. So this is the given line that I have taken, and M is parallel to L and N is parallel to L. So what we have to prove? We have to prove that these two lines are actually parallel to each other. And we have T as a transversal, and T being the transversal. Now what we have to prove over here? We have to prove that the line M is parallel to the line L. This is the thing that we have to prove, that the line M is parallel to the line N. So let's just start the proof of this one. So first of all, let us suppose if I have taken the angles as nothing but angle 1, angle 2 and angle 3. So first of all, if I'm talking about the line L and the line M, if in the line L and the line M, since the line L is parallel to the line M, it implies that angle 1 is equal to the angle 2. Why so? Because of the corresponding angles axiom, they should be equal to each other. Furthermore, we can say that in the line L and the line N, since the line N is parallel to the line L, it implies that angle 1 is equal to the angle 3, again due to the corresponding angles axiom. Again, we can say this by the corresponding angles axiom. Now, furthermore, what can we say about these two conditions altogether? Let us suppose if I'm taking it as 1, I'm taking it as 2. So, we can say that from 1 and 2, angle 1 is equal to the angle 3, which is equal to the angle 2. And furthermore, we have concluded that angle 2 is equal to the angle 3, which implies that they form the corresponding angles. And if we have a pair of corresponding angles in between the two lines, it implies that line M is parallel to the line N by the converse of the corresponding angles axiom. So hence it is proved that whenever we are talking about the lines which are parallel to the same line, then they are definitely parallel to each other.